Hello everyone. In the second video of units and dimensions, let us see what is a unit. Unit is a standard measure. What is unit? Unit is a standard measure of any physical quantity. So the important thing that to be noted is it is a standard measure for any physical quantity, right? The desirable features of standard unit. What features a unit must have? The standard unit should be a standard unit should be consistent. It must be consistent, reproducible, invariable, there must not be change in it, and easily available. And easily available. For what? For usage. So these are the desirable features of a standard unit. Now let us see measurement of a physical quantity. Measurement of a physical quantity. Right. There are two steps which are involved in the measurement of physical quantity. Let us see what are the two steps. First step is choose a standard value. Choose a standard value as a unit of measurement. As a unit of measurement. This is first step. And second step is find how many times find how many times that unit how many times that unit is is contained in the given physical quantity. The given physical quantity. For example, we have selected a standard value as a unit. Let us consider that as centimeter, right? Now we have to check that centimeter which is selected as a standard value is how many times of that physical quantity. Suppose if I take 2 centimeters, right? So that physical quantity is twice that of a centimeter. If I take 5 meters, meter is a standard value as a unit, and the given physical quantity is how many times of meter? It is 5 times of meter. So these are the two steps involved in the measurement of a physical quantity. So what is a unit? Unit is also a value. That is an important thing to be noted. Unit is also a value. Generally, what we'll think unit as, we'll consider unit as just a name, but actually unit is also a value. Hence, all algebraic operations are possible with units. That means when we consider unit as a value, algebraic operations can be possible with what? Units, right? Let's take example to understand this concept. So example Let's take first example as centimeter into centimeter. What can we write this as? Centimeter square. And second one is meter square upon meter. So we can write this as meter, because meter in the denominator and meter in the numerator get cancelled. As it is meter square, we'll get what? Meter. So algebraic operations can be possible in units. So the two examples clearly says that we can go with what? Algebraic operations with units. Every physical quantity is expressed as number followed by its units. Every physical quantity is expressed as number which can be represented with n and unit, and its unit, that is represented with what? U. So mathematically, if we write a physical quantity, we can write physical quantity P is equals to numerical value that is n into unit, that is represented as U. So I can write symbolically physical quantity is equals to Nu, where n is numerical value and U is what? Unit, right? And the important thing that to be noted is magnitude of a quantity, magnitude of a quantity, that is nothing but here P, does not change with choice of unit, does not change with choice of unit. So we can write P is constant. P is constant because as it is not changing, we can consider P to be constant. When P is constant, we can write Nu is equals to constant, because we know that P is equals to Nu, and from this we can write N1 U1 is equals to N2 U2. So then we can write N is equals to P upon U. So from this we can write numerical value is inversely proportional to unit. So greater the numerical value, lesser the unit it is, and lesser the numerical value, the unit will be greater. Let's take example to understand this. Example for this is height of a boy. Height of a boy. What is height of a boy? Let us consider height of a boy is 1.5 meters, right? So this can be written as in centimeters 150 centimeters. When it is 1.5 meters, unit is greater, so numerical value is less, because numerical value is inversely proportional to unit. As numerical value is greater, unit is lesser. So as we have written, magnitude of quantity does not change. Here height of boy is 1.5 meters, or that is equal to 150 centimeters. So here magnitude of physical quantity is not changing, even though we are changing the units. Earlier we have taken meter, now we have taken centimeters, but magnitude of the physical quantity is same in both the cases, but there is change in unit. As we have given relation above, numerical value is inversely proportional to unit, we can say greater the unit, greater the unit, right? If n is increasing, then unit is what? Decreasing, as numerical value is inversely proportional to unit. If numerical value is decreasing, then unit is what? Increasing. So you have seen here 1.5 meters, unit is greater, so numerical value is lesser. If we are considering the same value as 150 centimeters, here number is numerical value is greater, so unit is what? Smaller, right? So let us take one more example. Distance between distance between school and home of a boy is 2 kilometers. 2 kilometers. If you write that value in meters, we will write it as what? 2000 meters. So again, in this case, 2 numerical value which is lesser, kilometer a unit which is greater. So when you are converting this into meters, 2000 numerical value which is a larger number, whereas meter a smaller one, right? Hope you have understood this particular concept of unit and measurement of a physical quantity. Thank you.